Thanks for watching this screencast. This screencast is all about step functions, and our objective is learners will be able to graph a step function given its rule. So Panthers, we need to define for you the greatest integer function. The greatest integer function is a function that yields output values that are the greatest integer less than or equal to the input value. And the way that we denote that often in mathematics is this way, by putting a kind of a double bracket on each end of a number. So this would be like the greatest integer function of x. Sometimes this is called the floor function. Sometimes other textbooks, the one we use, uses this notation, but other textbooks will use this notation, where they'll put the number or the input, and they'll put almost like a bottom left and bottom right corner, if you will. So here's some examples of the greatest integer function. We need to find the greatest integer function output value for 3.6. So what this function will give back to you is the greatest integer. The integers are the counting numbers and their opposites. That's less than this number. It's 3. Right? What's the integer that's the biggest one that's less than this number? It's 3. Here's 7.9999999. What's the biggest integer that's less than that? It's not 8, right? It's 7. Good. The greatest integer output value for 5, since it says give me the greatest integer less than or equal to the input value, since 5 is an integer, is 5. Alright, be careful here. This is the one that students often miss. What's the greatest integer output value for negative 2.78? Negative 3. That's right. Negative 3 is the greatest integer that's less than this. It's not negative 2. Be careful. So Panthers, here's my important question to you. What would the graph of f of x equals the greatest integer function value for x look like? So let's see if we can come up with an answer. I think that for all of the values between x equals 0 and x equals 1, the output value would be 0. Do you agree with that? The greatest integer that's less than any number between 0 and 1 is 0. So I need y equals 0 for all of these values. And I got to decide what the endpoints look like. What would the greatest integer output value be for 0? It'd be 0 itself, wouldn't it? But should I make a filled-in dot at 1? If x is 1, the output value is not going to be 0 anymore. It's going to jump up to 1, isn't it? So what I'm going to do is I'm going to put an open dot here at 1, and it didn't probably show up as open, but it is. And then for all the values from 1 to 2, the output value will be 1. So I've got a filled-in dot at 1, all the way to an open dot at 2. Between 2 and 3, what's my output value going to be? 2, that's right. Fill it in here. Leave it open there. From 3 to 4, I'm going to get 3. Do you see the pattern here? And I can keep going. Between 4 and 5, I'll get 4 as my output value. Between 5 and 6, I'll get 5. I've got a little part of the graph here beyond 6. I guess I'll draw it there. I can even work backwards. For all the x values between negative 1 and 0, my output should be negative 1. But not at 0, because that jumps up here to 0. Between negative 2 and negative 1, I'll get negative 2. Between negative 3 and negative 2, I'll get negative 3, and so forth. You could fill this whole thing in. I think that this is a pretty good sketch of what the greatest integer function would look like. Sometimes we call this the step function as well. And I think the reason we call it that is because it literally looks like a set of steps, a set of stairs. So let's graph a couple of step functions, a couple of greatest integer functions. We'll start with this one. F of x equals 2 times the greatest integer of x. And we'll kind of go about this the same way we did making the basic function graph. we'll think about each x value and what our output value should be. Between 0 and 1, my output value should be 0, but then I got to multiply that output value by 2. And 2 times 0 is still 0. So here, from 0 to 1, not including 1, I need an open dot. What about between 1 and 2? Well, the greatest integer value for everything between 1 and 2 is 1, but this 2 is going to multiply that and actually make it a 2. So between 1 and 2, I need an output value of 2. What's going to happen between 2 and 3? The greatest integer value of all the things between 2 and 3 is 2. 2 times 2 is 4. See how that 2 changed this graph? It makes the steps taller, doesn't it? For all the x values between 3 and 4, I'm going to get a value of 3 here, and 3 times 2 is 6. And I think the next x values are going to be off my graph. Let's work it the other way. What about everything between negative 1 and 0? Everything between negative 1 and 0, this is going to be a negative 1. Negative 1 times 2 is negative 2. Between negative 2 and negative 1, I'm going to get negative 2 here, which would make our output value negative 4. Hopefully you see the pattern by now, don't you? Between negative 3 and negative 2, we're going to get negative 3 here, which means I need a line segment there at y equals negative 6. And there's a pretty good sketch of f of x equals 2 times the absolute value function for x. Okay, this one is for you. Try to make a sketch of the graph f of x equals the absolute, not the absolute value, excuse me, the greatest integer function for x plus 3. Pause the video, see if you can make the sketch, and then hit play. Let's talk about it. When x is between 0 and 1, the greatest integer function value is 0, and 0 plus 3 is 3. So for all of these x values, I need y equals 3. From here to there, not including that last point, between 1 and 2, the greatest integer function value will be 1, and 1 plus 3 is 4. Between 2 and 3, this should give me 2, and 2 plus 3 is 5. Between 3 and 4, this is 3, so I need 6. Do you see what that plus 3 did to our graph? Between negative 1 and 0, this should be a negative 1, so I need y equals 2. Between negative 2 and negative 1, this should be negative 2, and negative 2 plus 3 is 1. Do you have enough information now to complete the graph? I hope so. What did that plus 3 do to this function? It shifted the whole graph up 3 units. It took the same graph that we had for f of x equals the greatest integer function of x and added 3 to the output values. There's the sketch of what we're after. Thanks for watching.